slide deck, like presentation, intro for like 5 minutes. And then I have a GitHub repo that I'm going to be kind of walking through and initializing a new subgraph from scratch, building everything out, deploying it, and then also publishing it to the decentralized network. So the name of the workshop is Building Rich APIs on Celo, and I spelled Celo wrong here because I was just making updates at the last second with the graph. My name is Nader Dabit. I'm a DevRel with Edge and Node, and I also work very closely with the graph. Now, I've only been in this space for a few months, so I kind of have been in the Web 2 space. I was actually working with AWS for over 3 years before joining the graph in April, or joining Edge and Node in April. And really, up until April, I had almost no experience building out anything in this whole entire ecosystem. And one of the things that kind of really drew me to the graph, and there are a few other really interesting projects out there, is that it kind of fills out this fundamental piece of infrastructure. If you want to build out a front-end application, you need some performant API layer, and you want it to be decentralized, and the graph kind of fits that bill. So I started off working just as a software engineer, local startups, went into consulting, training, went to AWS working with developer relations, led the mobile and web team there for about 3 years. And then now I'm working with Edge and Node, been there since April. So if you haven't heard of the graph is an indexing protocol for querying networks like Ethereum and IPFS. We support about 15 or 20 networks at this point. And we're also now expanding into other chains as well. So we believe that the future is not only going to be EVM compatible, but all of the other different chains that are out there, combining different data, building out rich front ends, rich applications. So in the past, if you wanted to kind of build out a front-end application or just any application with any non-trivial data access pattern on top of a chain, on top of blockchain data, you typically were creating and building your own indexing servers. Now you can hit a chain and query, a really basic query, so you can get like a single piece of data. You might be able to get a small array. But if you need to, do fundamental things that you typically need for an application, like you need filtering, sorting, you might need to have some compute happening to kind of get the selection set of data that you need. Most of the time you're building out your own indexing server. And this is costly in a few different ways. First of all, it's very resource intensive, so anytime you need a new data access pattern exposed to your application, you have to go in and build that out yourself. Anytime you need something changed, you're out there, you're in there just controlling that API and you're building everything yourself. But also it kind of breaks the whole fundamental idea around decentralization in the first place, because if you're kind of taking all this decentralized data and you're storing it in a single database, then it's no longer decentralized. It's also a single point of failure. So that's kind of where the graph comes into play. With the graph, you're able to basically create these subgraphs, which basically deploy open APIs on top of any smart contracts. So like I mentioned, right now there are about 15 to 20 different networks that are supported. But let's say that you wanted to kind of build out an API on top of an NFT marketplace, maybe combine a few NFT marketplaces together, expose all of that, and then you can still send transactions from the front end. You can basically spin up a subgraph, and really with not a crazy amount of code, have something up and running that allows you to kind of have a really performant, rich API that you can then use on your front end with everything that you would typically need, pagination, sorting, filtering, all of those things, relationships as well. So there's a lot of different applications using the graph at this point. Some of the more popular ones or famous ones might be things like Uniswap and synthetics and Foundation. But if you go look in the Graph Explorer, you can kind of see a good idea around what's out there. Now, this is kind of like a picture of the newest UI that we just launched a few weeks ago that exposes a lot of the things that were not available in the UI before. So now you can actually signal on subgraphs. You can publish your own subgraph to the decentralized network, whereas in the past, it was a lot harder. The launch that happened at the end of 2020 was mainly focused on kind of like having the actual infrastructure in place and the smart contracts in place. The launch that we did a couple of weeks ago builds out a UI on top of it, so really anyone can kind of participate. And with the, I would say, like launch of this new interface, it kind of has some of the same things that were there before, but you're able to do a little more as far as like interacting with the actual network itself. You're always able to go in and create queries and play around with your API. Like in this view here, we're kind of checking out the playground, which is the Explorer. It's like an API Explorer. You can think of it as something like Postman or something like that. So the network itself, the decentralized network launched in December of 2020, but just a couple of weeks ago, we had another launch where we launched Subgraph Studio and the new Graph Explorer, which I'll kind of walk through in just a second. But to participate in this new launch, you can participate in a few different ways. You can be an indexer, which means that you're running infrastructure yourself, you're running a decentralized node, and then when someone deploys a subgraph, you can choose to index that subgraph, and then you start making money based on the amount of queries that subgraph receives. So you can earn rewards as an indexer. You can also earn rewards as a developer. So if you're a regular, just a subgraph developer, and you have a good idea for an API, you can build it out, launch it to the decentralized network, an indexer picks it up. Anyone that uses it, if you're signaling on it, you start receiving a portion of the rewards there as well. So there's incentives, monetary incentives for people to kind of participate in the network in multiple different ways. So I kind of went over the Subgraph Studio, Graph Explorer. Those are the things we're going to look at. But the main point of this talk is to actually build something from scratch. So what I've done is I've actually built out an entire workshop that's written in Markdown, so you can actually copy and paste if you want to go back and ever build this thing out yourself. And that's kind of what I'm going to be following along with. And we're going to be building a subgraph, we're going to be deploying it, and then we're going to be publishing it to the decentralized network. And the smart contract that we're working with is a Celo smart contract for Uniswap. So this is kind of like what it looks like as a subgraph developer. This is kind of where the most, I would say, action happens for developers. They're building subgraphs. If you're running an indexer, it's not a ton of, work once you're there. But building subgraphs is more creative and I would say fun, and at least to me. So you initialize a subgraph with the CLI. You go in, you define which data sources you want to index. So like you might say, okay, I want to index data from this NFT marketplace, this NFT application or whatever, or maybe a DeFi app, whatever. So once you've decided which data you want to index, you then define the data that you want to expose via that API. So let's say, for instance, again, an NFT marketplace might have like a token. A token might have different properties, like an object or something. Might have an ID, it might have a name, the owner address, things like that. So the entities are kind of like these objects that you want to be able to query for. Once you've defined what the data that looks like that you want to query for, you basically can then define the properties on that data in these mapping templates that we're going to walk through as well, and then you deploy. And then once it's deployed, you can interact with the subgraph in the actual user interface. Now, the subgraph that we're building here today is a little more complex than I typically like to do for like an introductory level talk. But I kind of like had an idea for what I wanted to do, and it was kind of mimicking this Uniswap. So once I actually started building it out, I realized this is quite a bit of code. So I'm going to be doing quite a bit of copying, pasting. But I also have another more simple subgraph that is for an NFT application that's also on my GitHub. So if you're interested in doing something with Ethereum or something a little more simple, check that out. All right, so the workshop is located at github.com/Dabit3. And the first thing that shows up should be this workshop. So the reason it's at the top is because I tried to run it this morning, and I found a bunch of things that were broken, so I made a bunch of updates. So my last update was like an hour ago. All right, so yeah, let's go ahead and start building. So the first thing I'm going to do is I'm going to go to thegraph.com/studio, but if you go to thegraph.com, you'll see that there is a new drop-down menu. So these two things are new here, the Studio and the Explorer. I'm going to go ahead and click on Studio, and this is where we go ahead and connect our Ethereum wallet. So I have a basic test account here. I'm on the Rinkeby network because I'm going to be deploying to Rinkeby, not to the main network. All right, so we're connected with our wallet. So I'm going to go ahead and create a subgraph. So the subgraph is going to be for Celo, and it's going to be Uniswap, so I'll just call it that. And then once the subgraph has been initialized in the dashboard, we can now go to our command line and start creating some code and deploying and pushing it up. But here in the UI, we now have some really useful information. We have the slug for our subgraph, which is this right here. We have our deploy key, which we're going to be using for authorization. We can also define metadata and tags. So if we have deployed our subgraph and we want it to be discoverable, this would be where you put that metadata. We have a little bit of documentation around installing the CLI and things like that, but all of this stuff is available in our documentation as well. So once we've created the subgraph definition in the studio, we can go to our command line and start writing some code. So I've kind of already done these things. You would install the Graph CLI, which I've already installed. And then once the CLI is there, you should be able to have the graph binary. All right, so we have the graph installed. Next, we want to go ahead and initialize a new subgraph. Well, this is where I'm going to have to do a little bit of extra writing of code because we merged something in last night to enhance the Celo support, but it does not automatically pull down the ABIs, so I'm going to be doing that from scratch, but hopefully the next time you look at this later today or even later this week, it should be fixed. So I basically have like this main part here that's kind of telling what to do, and if this doesn't work, you come down here. So I'm going to go ahead and go down there because I know for a fact that that part doesn't work properly. So you initialize with graph init. Here we're passing in a few different things. We're passing in the main contract that we're going to be building this subgraph on. And if you don't pass these arguments, it'll prompt you for these, so you can do it either way. So the contract name that we're working with is factory, and this is coming from the Ubiswap smart contract, which I've linked into this in this documentation as well. We're now defining the product as Subgraph Studio because we also have the legacy subgraph hosted service, but we're now kind of using the new one, so we're defining the product as like Subgraph Studio. You can make it shorter by just saying -- studio. And then we're also passing in the from contract. Now this is not going to be extremely helpful here because of our bug for Celo that we have just like right now. But if you're doing this on Ethereum or in the future of Celo in a few days, hopefully, it actually will go in and pull down all of the ABIs for you and download them locally, and it'll also create some boilerplate code for you based on any events that were emitted in that contract. So I can go ahead and just press enter. This is going to prompt me for the subgraph name. Typically, this is going to be whatever you put here, but it doesn't have to be, so I'm just going to copy the slug. Here we can choose the network. These are all the networks that are supported by the actual service. So even though the CLI is going to throw me an error, we can still choose that. This is where it should be fetching our ABIs, but since we don't have those yet, since the CLI doesn't support that, we need to go ahead and create those. So I'm in an empty directory, so I'm going to create another empty directory called ABIs, and then I'm going to create a new file called factory.json. And then we're going to go ahead and open this up in our text editor. All right, so we need this ABI here. So I've kind of linked to those here, but you can also get these directly from the contract and the Explorer. So I'm going to copy this ABI here, and paste it, save it, and go back here. So now we can say ABI/factory.json. And this should now initialize some boilerplate code for us based on that ABI. So I can go ahead and open this up in my text editor again. Might be too big. Is that readable? Yeah. All right, so we have this new folder here called Celo Ubiswap. And the CLI is still doing some stuff, but now we have our subgraph. So like literally this is kind of like the general components that you would see in a subgraph. The main three things that you work with are going to be a GraphQL schema, the subgraph YAML, and the mapping templates, which is going to be like where you're actually writing some logic. So we're going to go ahead and open those three up. The graph uses something called GraphQL, and if you're a front-end or even a back-end developer, you may have heard of it, but it's basically an alternative API implementation than REST. And it's a query language, but it's also a way to make mutations and real-time updates, and it's becoming pretty popular. And there are a lot of trade-offs, but mostly benefits, in my opinion, to use GraphQL over REST, but that's kind of outside of the scope of this. But GraphQL is a typed type of thing. So like when you're working with REST, you might not actually have to have types for your application to work. With GraphQL, you define the types that you would like to work with. So a lot of times, these days we're writing TypeScripts, type languages, so it kind of fits very well with that. So what we want to do for Ubiswap is we want to go ahead and define the data that we want stored as entities, and we can just match those to a GraphQL schema. So what is the data that we want to be exposed? Now, if I go ahead and open up a new window, let's go ahead and take a look at the existing Ubiswap subgraph and kind of look at the data that comes back. And I've linked to that as well here. So if we look at the existing live Ubiswap subgraph, you can kind of look on the right-hand side here. And this is the way that GraphQL does kind of auto-documentation. It's called Schema Introspection. It looks in your GraphQL schema. It looks at the queries that are available, and it gives you kind of documentation on how to do those queries. So here we can say, we can get tokens, we can get pairs, we can get swaps. So let's say we want to get a swap. I might say swaps. And then you want to get the ID. You might want to get the pair. And then you might want to get the token. All right, so that's a basic query, but you can run it, and it kind of comes back. But the idea is here, like any data that you want available here is going to be a type. So we're not doing the entire Ubiswap GraphQL schema, or even the whole subgraph, because it ended up being quite a bit of code, like I mentioned. But even with the dubbed down version that I'm doing now, it's quite a bit of code. So let's go ahead and copy this schema and kind of walk through a few of these types. So the implementation that we're working with today, the main things that I want to return are pairs and swaps. So like what pairs are available, and then what swaps have happened. So to kind of make this work, I have these two main types, type of pair and a type of swap. We have the different fields that we want. We have the different relationships. So like I mentioned, you can do one-to-many or many-to-one relationships. Here we have a one-to-many relationship. The swap is derived from the pair field. So you can do that by using this directive, which is recognized by the Graph Cli. So you kind of define the data that you want here. If you work with GraphQL, this may be familiar. Even if you've worked with the type language, this is probably familiar. So once we've defined all of the data that we want stored, we can now continue on. So I have these four main pieces of data: tokens, transactions, pairs, and swaps. So we can go ahead and close that and continue on. So the next thing we want to do is, now that we have the data defined, we want to tell the subgraph to use that data to listen to different events that are happening in the different transactions for this contract. So when you're working with a smart contract and you do something like a transaction or something, you often emit an event, and then within that event you pass in different arguments. So the way the graph typically works is you can listen to any of, or you can basically, I would say listen, or you're basically mapping over all of the transactions and looking for those events. And then with that event data, you can store things. So you could, theoretically, people are even building out subgraphs without saving data to chain at all, because if you know you can get that data from the event itself and you don't have to store it, then you can often save money on actual transactions and things like that. On saving things to chain and stuff like that. So the idea, though, is that you kind of listen, or you look for these different events, the data from these events, and you save that to your subgraph. So the way that we kind of define that, everything that goes on within your subgraph is defined in this subgraph.yaml. If you've ever written YAML, this is familiar. If you've ever even written something like infrastructure as code on AWS or something like that, or any cloud provider, this is also probably going to be familiar. You're kind of just telling the subgraph, or the indexer, what to do with the subgraph. So you're saying, okay, I want to use this contract, I want to save these pieces of data, and then when an event happens, I want you to invoke these functions. So that's what we have here. We have this data source, we have our address, we have the ABI locations that we want to work with here. So this is kind of like some boilerplate that was created for us. I'm going to be updating a lot of it. But then we have our event handlers. So like when an event happens, fire this function and pass in these arguments, and then we're going to manage that. We're going to deal with that in our mappings. So let's go ahead and get started updating this to work with Ubiswap. So the first two entities that we want to define are pair and token. And these are off of the main factory contract. But the factory contract inherits another contract, and we're going to build out another template for that in just a moment. But we're going to start with the main contract here. So the entities are going to be pair and token. The next thing we want to look at is we want to add an additional ABIs, and these would, in theory, typically be pulled down by the CLI, but we're going to have to like go ahead and copy these ourselves. But we also need to work with the ERC20 ABI, because even though we're not, of course, like creating any tokens or anything like that, we are interfacing with them. So in our ABIs here, we can actually go ahead and say we want to also have one more called ERC20. And for our event handlers, we already have this event handler here, which was retrieved basically from our smart contract, from our ABI, I'm sorry. So we when we initialize this, we gave it that one ABI. It goes into that, it looks for all the events, and it creates like default event handlers for us. But I'm just going to change the name of that to handle new pair, which is kind of the language I use, and it's not even that big of a deal. I could have probably kept it the way it was. And then the last thing we can do is we want to define the start block. So by default, if you don't define a start block, it starts indexing data from the Genesis block. So this kind of saves a lot of time. You can kind of say, okay, whenever this smart contract was deployed, let's start indexing from there. And there's even an idea called grafting, which if you're deploying and you're testing out your subgraph and you have an error in any certain block, you can start indexing again from that block going forward to make it more efficient. So we defined our start block. Now we're kind of ready to go to the next steps. That's our main factory template. So it kind of looks like this. And then we want to also work with a contract that is inherited from this contract called pair. So I'm just going to copy this template here, and it's doing similar things. It's doing the exact same ideas and things, but like different actual data. So here we are dealing with this swap event. So we have the pair event, and then we have the swap event. And we now are referencing a couple of more ABIs. So we have our pair ABI, and we have our ERC20 ABI. So we don't have those yet, so I'm going to go ahead and create that now. ERC20 JSON, and then pair.json. And in the workshop, I have them here, so I'm going to go ahead and copy those. All right. So we have our ABIs now, and we're kind of ready to move on to the next step, which is we're done. The subgraph is now finished being created, except for the mappings, which we're going to go ahead and create in just a moment, but the actual configuration and all that stuff is done. So what we can now do is, based on a combination of our GraphQL schema and our mappings, we can do some, a GraphQL schema and our subgraph YAML, we can do some code generation. Now, when we are working in these mappings, we're going to be doing a couple of things, but the two main things you're going to be doing are interacting with the smart contract itself. So you might be calling out to another contract to get some data. And then you're going to be interacting with the graph node, which is the indexer that's running and storing all of this data. So let's say you deploy a smart contract and you then deploy a subgraph on top of it. You're indexing data. You're storing data in your node. And then you want to go and retrieve some of that older data. You can do that directly from the mappings. So we provide a library called GraphTS, Graph TypeScript, that allows you to have a nice API on top of interacting with both the graph node as well as the smart contract itself. And we do code generation for you to kind of get you set up. So at this point, I can go ahead and run inside of my new directory here. I can run graph code gen, and then this should go ahead and generate the code that we're going to need to build out our mappings. So if this runs successfully, we should now have a folder here called generated, and this has a schema, and it has this factory folder. The two things that you can do with these methods and these functions and classes, interact again with this contract itself or interact with the graph node. So that's what we're about to do in the mappings. So by default, it generated like some boilerplate mappings. We can go ahead and delete that, and we're going to go ahead and write a bunch of code. When I say write, like copy and paste, but I'm going to walk through some of it just to kind of give you a general idea. But this is the mapping we're about to kind of like walk through. And I'm going to kind of walk through the two events because those are the two things that we're really interested in, right? Like dealing with the swap and dealing with that pair. So again, like typically write an example for a workshop like this that maybe has like 40 or 50 lines of code, but again, this Ubiswap thing was a little large. And this is a really dumbed down version of that. So like we have these two handlers that we're working with in our subgraph.yaml. We have handle new pair, and then we have handle swap. So those are invoking these functions in the mapping. So here we have defined handle swap and handle new pair. So when someone creates a new pair, we basically first see if we've already saved or created this token in our indexer. And if we have not, we go ahead and create it. And then we continue on. We do the same thing with the second token. So for a pair, you're going to be pairing up two tokens. So you have token 0 and token 1. From there, we go ahead and define all of the properties that we want on the pair. So we have, when we defined our pair in the GraphQL schema, we have these fields, right? ID, token 0, token 1, created at timestamp, and created at block number. This is where we're writing that code. We're saying we want the pair to be a new pair. We're going to then say that the token 0 is this token that we just referenced or created earlier. Like we either had it already or we just retrieved it, or we just created it, I mean. We're setting the two fields, token 0 and token 1. We're setting the two fields created at timestamp and created at block number. These are coming in from the event. And then we go ahead and save everything. So when we call .save, we're saving this to the graph node, and which makes it then available to anyone on the front end. So this is kind of what a typical mapping template looks like. You're kind of like working with the handler function. Data is coming in from the event. You're either saving that data directly or you're using that data to call some other API and then like, modifying it and then saving it. So if you're like want to know how this stuff works, definitely dive into some of this code and maybe play around with it. Look at this subgraph and then look at the actual production Ubiswap subgraph, spot the differences, see the things that I left off and things like that. Excuse me. All right, so now that the mappings are done, we are finally ready to deploy this thing or try to deploy it. We just wrote a lot of code. Don't know if it's going to work. Hopefully it will. So what we can do now is we can run a build locally just to make sure it doesn't break, or we can go ahead and deploy to the studio. So I might just go ahead and run a build just for the heck of it. So I can run graph build. If everything works successfully, you should see that you have like a build folder that's created. So let's go ahead and launch it and then test it out. So if I go to where I created my subgraph earlier in the studio, I have this deploy key. So I can go ahead and copy that, and I can go ahead and run graph auth for authenticating. And here it's going to prompt me for my deploy key, and then we set that deploy key, and now we have access, or we're authorized from our CLI to deploy. So I can go ahead and run graph deploy -- studio. And then I can go ahead and paste in the slug for this subgraph. And then give it a version, and then we'll see if this works. This should go ahead and deploy the subgraph that we just wrote from scratch, and then once it's deployed, we should immediately start indexing all of this data. So what it's doing now, if this launch deployed successfully, then you should see like this UI updated here. So now you see we have progress at 84%. The reason it's at 84% is because we set a start block, and that's kind of the percentage of blocks, the delta between like the number that are there, I guess, and where we started from. So now the indexer is doing work. It's like going in, it's looking at each one of those transactions. It's looking for the data. It's saving it, keeping going, and then like as it goes, the progress should continue to go up. And we can go ahead and actually start querying. So, you know, I mentioned earlier we have the schema introspection. You can see how much smaller our schema is. We only have 4 entities. Well, we might want to go ahead and start doing some queries. So I might say, give me like the first tokens or something like that. Actually, let me just refresh because it already had that. I don't have to rewrite it. So I might say, let's go for these tokens here. Run the query, excuse me. And we have like the current state of our API. Like we're still indexing more tokens, but like whatever tokens were created at this point. So you probably wouldn't use this data in production until it finished syncing, but like it should finish syncing fairly quickly, like for this amount of data. We also have, I've also kind of like put a few other queries that you might want to work with. So let's say we wanted to get the swaps. I don't know if any swaps have come up yet, but if they have, this should bring them out. Here we can kind of see we have like the amount, we have the tokens, so the Celo dollar for the Celo native asset, Ubiswap token, Celo dollar, all these different tokens. So like we're now getting all that data. We might want to do something more interesting though. We might want to say we want to do some like pagination or filtering or sorting. So let's say we want to like order by timestamp and then reverse the direction. So I can just pass in an argument here. And then this should now return in descending order. I might even say I want to get like the first 10. And then we can do pagination and stuff like that. And then maybe you just want to get the first 1. This should only return 1. So that's kind of the intro to building with Celo on the graph. I know that was, we didn't go through all the code just because it was like so much freaking code. So if you're interested though, like I would definitely check out this workshop, as well as if you look at my GitHub, there's this other workshop for that I'm going to be giving tomorrow at ETHCC. That is more of a basic subgraph, like I would say introductory level, this building a subgraph workshop. So check those out. Check out our documentation. We have a Discord. And Twitter, the Graph protocol, or Graph protocol, graph.com/Discord. Yeah, that's it. So yeah, thank you for attending. Does anyone have any questions or anything like that? Yes. Mm-hmm. Shed some light on like where the current development is for improving that feature. I don't have any context there, but I would say just I can, if you give me your info, I can check with the developers today and come back to you. Yeah, so subscriptions are like, Graphql subscriptions are typically just like a specification versus like an implementation detail. And on our end, we kind of like try to not, at least today, try to like nudge people towards using the built-in subscriptions. Instead, we try to tell people to maybe use event listeners for the actual smart contract. Even though we have a lot of Subgraph or apps in development, I mean in production that people are using subscriptions for, I would say it's not like, I would say to the point where I would consider it like high traffic production ready for subscriptions. But we are actually working right now on implementing like a production, like next iteration of subscriptions, as well as possibly like mutations. But yeah, the implementation is WebSockets. Yeah. Right. Yeah, basically. Yeah, the node itself has like some functionality built in, but it was like a naive implementation, if I understand correctly. I don't have all of the details there. Yes. Oh yeah, well we haven't deployed to a decentralized network yet, so maybe we can go ahead and do that. So like right now, this is running in a hosted service type of thing. So this is kind of like a sandbox environment. Once you're ready to actually deploy and publish to the decentralized network, you can actually do that here. So here there's like a button, you click publish. I'm going to go ahead and publish to Rinkeby because I'm not going to do this to the main net. And then we should be able to go ahead and, I think I need to connect my wallet or something. No, I'm connected. Let's see here. Oh, I'm querying another network. So it says you can't publish a subgraph that is querying a network other than mainnet. Oh, that's right, yeah, because when we launched this a couple of weeks ago, we don't support Celo yet for the decentralized network. So like if you were doing Ethereum or one of the supported networks for the decentralized network, you would be able to just click publish right here. And then you can publish to Rinkeby kind of like testing, and then you would publish to mainnet. And you can kind of see, like, if you go to the Explorer, these are the actual subgraphs that are live on mainnet, which really just launched, like I mentioned, like 2 weeks ago. This UI here. So, yeah. Any other questions? Yes. What's that? I'm sorry. The auditing? Oh, the auditing for our smart contracts? Oh, it's very complex. It's like one of the probably the most important things for an understand that we spend time and money on. I know it's very expensive, but I think we outsource. Yeah. Oh, okay. So you're worried about the data integrity for the data that you're pulling from another subgraph. So basically, part of the network has a lot of different things built in to incentivize people to serve the proper data. Things like slashing, and there's incentives for like if you publish a subgraph with data that isn't the right type of data, you lose money as a subgraph developer. So there's things like that. So I mean, like I would say the incentives that are built into the network and the protocol itself try to incentivize and do incentivize that data to be the proper and correct data. But I think over time, as you see subgraphs and developers that are out there building out these things over the next few months and stuff, people are going to build reputation and things like that. And I think like everyone will have a better understanding of that. But like, yeah, that's kind of my answer, I would say. I have a bunch of swag too, so when I get off the stage, if anyone wants a t-shirt or stickers, let me know. What's up? A reorg on the smart contract? On the... Like if we deploy a new version of Graph Node software or something? I would say typically the way that those types of things happen is that someone would deploy like another version of the subgraph to kind of take into those considerations, but the one that's already deployed should not have anything happen to it at all. If I understood your question correctly. Sorry, yeah. All right, cool. So I'm gonna have some stickers and swag. I'll be hanging out. So if anyone has any questions, let me know. Thank you.